Alrighty, so our first ones, what are we looking for on these? Circle which one has a greater frequency. So on number one, would it be yellow or green? Yellow or green? What do we got? Green? All right. X-ray or gamma rays? Gamma. UV or violet? It's actually UV. If you look at it, the visible light, it's just this little slice. So while it looks like violet is farther over, that's just because that little slice has been expanded. So visible light is right here, and then UV is outside of that. So those are those three. And then out of all the six, which one has the longest wavelength? I think that's yellow light, isn't it? Yellow light. And then which one has the highest energy? That would be your gamma. Exactly. So those will kind of be some similar questions, but if you did the review and you did it a couple of times, it's still open, then that'll prepare you for the quiz tomorrow. All right, so today we're going to look at our formulas and some problems with those. They're pretty easy. I can find them. There we go. All right. So our first one is called the speed of light equation. So that one was C is equal to frequency times wavelength. And it can be put in our nice little triangle, so we don't have to worry about doing too much algebra. And speed of light is a constant. It's equal to 3.00 times 10 to the 8th. Oops. Meters per second. Frequency is measured in hertz, which is abbreviated HS. And I know y'all had this stuff filled out. I'm just writing it because we'll need it in the problems. And then wavelength can be measured in meters or nanometers. But we talked about yesterday that if you measure it in, since you're using this formula, it's going to have to be converted to meters. And that conversion factor was 1 nanometer is equal to 10 to the negative 9 meters. All right, so those are all things that we're going to be using. So on the first one, it says find the frequency of a photon with a wavelength of 434 nanometers. So if I look at my little triangle, I'm trying to find the frequency. I kind of cover that up. And then that tells me it's going to be C divided by wavelength. And so then at that point, I just start filling things in. C is always a constant. So 3.00 times 10 to the 8th meters per second. And I divide that by my wavelength, which is a nanometer. So I have to convert it to meters. So all I'm going to do is take my 434 and add times 10 to the negative 9th. And that'll convert it to meters. So it's real simple. You don't have to do a big conversion process. So just take the number you have, tack on that. Since this number with exponents is on the bottom, you're going to have to put it in parentheses. So give that a try and put that in your calculator. And 3 sig figs, because my original number had 3 sig figs. 6.91 times what? 10 to the 14. And my meters would have been canceled out. I would have been left with hertz as my units for frequency, or I could have said seconds to the -1. Hertz may be a little bit easier just to memorize. It always goes with frequency. Any questions on that? If you got a really large exponent, it may be because you did not put this in parentheses on your denominators, kind of like Avogadro's number on that. All right, let's look at one more of those. So the next one now, I'm trying to find wavelength. So if I use my little triangle, I get the wavelength is equal to C divided by V, which is frequency. And I have my frequency, and I always have C because that's a constant. So I'm going to fill it in. So C is 3.00 times 10 to the 8 meters per second, and divided by my frequency, which is 5.10 times 10 to the 14 hertz. And once again, since this has an exponent, you'll need to put that in parentheses. We still have 3 sig figs. Get 5.88 times 10 to the negative 7. And my unit would be meters because I'm trying to get wavelength. So my seconds and hertz canceled out. Are we good on that? Once again, if you got some different exponent, like a large exponent, then it would have been because you put this in parentheses. All right, so just pretty 3 variable formula, and our energy formula is also very similar. So you'll have a quiz over using these formulas on Friday. You'll need to know the formula. I'll give you C and I'll give you Planck's constant, which we'll get ready to use in this one. So for energy, it's Planck's constant, H times frequency again. So this is your value for Planck's constant. And once again, we can put it in our little triangle. E, H, V. And energy, the units for energy are joules. So if we're figuring that out, then we'll end up with joules on that one. All right, so just look a couple of those. It says find the energy of a photon, and then we have our frequency. And once again, it has 3 sig figs. So my answer should have 3 sig figs. So this is just a straight plug and chug. I don't even have to move that around or anything. So E is equal to Planck's constant, 6.626 times 10 to the negative 34 joules times seconds. And I'm going to multiply that by my frequency, 4.57 times 10 to the 14th. So I want 3 sig figs, and my number is still going to be a pretty small number, but it's going to be larger than negative 34. So I got 3.03 times 10 to the negative 19th. And my units would be joules because we're trying to find energy. If you're choosing not to try these when I'm doing them and I'm asking you to put them in your calculator, I'm a little baffled because the problems with the exponents and in your calculator happens to have been the biggest problem that I've seen today. So I have a reason behind asking you to give them a try. My next one says find the energy of a photon with a wavelength of 690 nanometers. That's just 2 sig figs. So my answer can have 2 sig figs. So can I use that formula, this formula right away for energy? Do I have what I need? No, I don't, do I? because I don't have frequency. So what are we going to have to do first? Yeah, we're gonna have to go back and use our other one first. So my formula that I need to find frequency for, if I use my little triangle, its frequency is equal to C divided by wavelength. So I do have that. So I'm gonna plug that one in first. So my C is always 3.00 times 10 to the 8th meters per second. And I'm gonna divide that by my wavelength, but once again, it's in nanometers. I need to get it to meters, so I'm going to tack on that times 10 to the negative 9th. And then that's what I put in my calculator. And once again, I'd put that in parentheses with just 2 sig figs. And I have a large number being divided by a really small number. So my exponent should be larger than 8. Those are just kind of quick checks you can do. So I got 4.3 times 10 to the 14 hertz. And now I have my frequency. So now I can come and find out what I was actually trying to find, which is my energy. So my energy is going to be my Planck's constant again. 6 times 10 to the negative 34. And I'm going to multiply that by my frequency. So it's still going to be a pretty small number, but it's going to not be as small as 10 to the negative 34. So we want 2 sig figs, so you would round it at 2.8 times 10 to the negative 19. That's what hopefully you'll get. And then since we're trying to find energy, once again, energy, my units are always going to be joules. If you're taking physics, you might have already come across, or have taken, no, I think I would have already taken physics. If you're taking physics now, you probably have already come across joules. So pretty straight little formula, and that's what your practice is over today. You have the answers on it, so you can check yourself with regard to sig figs and make sure you got your exponents okay and your units. And there's some of both types of problems on your practice today. Does anybody have any questions? If you keep getting the wrong exponent, let me know, and then we can kind of look at how you're putting it in and make sure that it's just not a little mistake and you need to put something in parentheses or something like that. Ma'am? You what? You have this too. I'm going to tell you what my mind's not. This one, okay. Or something. Let's shoot.